So what we're going to start with today is we're going to go back to the GitHub repository, and we are going to download this again. If you have a Mac, you don't have to worry about this. This is a Windows thing, but there's a way we have to download this that if you don't do it that way, you're going to have a lot of problems in the afternoon. Okay. And I'll discuss that when we get there. So go to the GitHub site. If you don't know how to get there, Google my name, Alex McLean, GitHub. That'll take you to my account, and it'll take you here, and then you go to repositories, and then you go to INBRE Summer 26. Click on that, and then you should be on here. I'll just give a couple seconds so that everyone has a chance to do that. And again, if you have a Mac, this isn't an issue. This is something that happens on Windows machines that we gotta do this again. Okay, so once you're there, just like we did last time, click on this down arrow by code and click on download zip and get that downloaded, and it's going to look something like this on your Windows machine. And if you're having any issues online, please speak up. This is a very important step. Okay. Both Elaine and Yanan are monitoring the online part. Okay, at this point, do not double click the zip file. That's where things start to go wrong. So we're gonna right click on it, and you're gonna click extract all. And ask you where to save it. Downloads here. Okay, so now in downloads, there's the zip version of this, but then there's the unzipped version of this file. And for those of you using these computers, this is something you're going to have to do every day. You'll always have to do this to start because they don't save your work from the previous day. These things, they wipe off all the files at the end of the day. Why does it have your work from the previous day? Oh, does it? Okay.
Yeah, I had the zip file yesterday.
Okay. Well, I guess you won't have to do it, but if you don't see it on there, this is the step you'd have to go through.
They got an error when they were under.
That's I'm not sure how to do that. If you did get an error when you unzip, okay, one thing you can do, if you do double click it, and it takes you here, right click and click copy, and then go to your downloads or documents, for example, and left click and paste. That's a equivalent way to do this. Okay, is anyone in the room having issues with that? No? Okay. So the reason why this is important, so now I'm going to go into this INBRE Summer 26. The file structure that we have here the fact that we have this what we're going to do in the afternoon is we're going to use some data that's going to be in this data folder. And the file structure of the fact that we have the week 1 foundations, next to it we have the data, below that we have the the root directory. That sort of organization is important for us when we want to download that data into R. The file structure has to be exactly like that, and I'll explain that more carefully. But if you have it like that, everything will work smoothly when we're in the afternoon session. And another benefit is that for those of you who had the HTMLs that were not looking like they looked on the screen yesterday, this will fix that issue as well. So then let's go to the day 2 AM HTML. Double click on that. And then we're at our notes for today, and these will have all the edits in them.
Dr. McLean, can you screen share, please? We're not seeing it for Zoom.
Screen
It is
share.
shared already. I can see that.
Maybe check that out. Some people are saying that it does say I'm sharing my screen here.
Hi, this is Cindy. I can see it now.
Okay. Okay. All right. So yesterday we installed R. We installed R Studio. We created a data frame. We did a mean. We created a Quarto document. Some of the fundamentals that we're going to continue with today. The first part of today, we're going to talk about the different types of objects that we are going to have in R. The main one of these is going to be a data frame or a tibble, which is basically like a spreadsheet. Okay, so we're just sort of building up to that, and we're going to talk about some of the different ones. We did vectors yesterday. Okay, vectors are just going to be a single string of data. And there's different types of data that we can have in R, and all three of these are different types. The first one are numbers. The second one are characters. Character variables. Character variables always have to have a quote around them. And logicals, true and false, mean true and false. Okay, we'll use logicals sometimes when we're indexing data, when we're looking for particular data. So these are the three main types of variables that we'll be dealing with: numbers, characters, and logicals. Matrix is just an expanse of vectors into, now we can have, instead of one row, we can have multiple rows. Okay, you won't use matrices much. They're used for linear algebra. If you've ever taken a matrix algebra course or a linear algebra course where you're doing matrix algebra, you would use those, but we won't use those. I'm going to skip lists for now. I'm going to go back to it. So the data frames and the tibbles, these are sort of the main things that we are going to do first. Yesterday we did data frames. Today we are going to do tibbles. They are basically exactly the same thing. A data frame and a tibble are very, very similar. The only difference is the tibble has some defaults that are nice. Okay, they are nice. For example, here we created a tibble just like we did yesterday with data frame of this thing called patient data. Now notice when we look at the patient data, it looks different than if it were a data frame. It just doesn't quite look the same. Let me open my R and I'll show you what this looks like as a data frame. So I'm going to copy this code. And again, anything you see in gray here is always going to have this copy button on the top right-hand corner that you can click to copy it. And I recommend you do this as well. Okay, so I'm going to paste this in here. And I'm going to change tibble to data frame. Data.frame. So you see, when we have a data frame, it shows us all the available data that we have. And when it's a tibble and we print it on the screen, it looks a little bit different. First off, it says a tibble. It says the dimensions of it. And also it gives us the variable type of all the variables that are in the tibble that we're interested in. Another nice thing about it is when you print a tibble, it will only show the first 6 rows. If you print a data frame that's 1,000 rows long, it will show you 1,000 rows. It actually won't go over 1,000, but it'll show you the first 1,000. That kind of just blows up your screen. A tibble will also not show all the variables. It'll stop at some point, and then it'll show you the rest below. We'll see this later. So it's the same thing as a data frame, just has some nice kind of features to it. Doesn't blow up your screen. It tells you how big it is. It tells you the variable type. So it's just kind of like a data frame with some nice bells and whistles to it. Later in the afternoon, we're going to read data in. And when we read data in, it's going to come to us as a tibble. So this isn't something we're usually going to create. You're going to read your data in, and boom, you're going to have a tibble right from the beginning. And it's going to have these nice features to it. So this is mostly what you'll be dealing with. And this is something that's that we're going to work through a lot today. Okay, we're good? Okay. So let's go back to R. First thing I also want to do, I want you to load in tidyverse. If you have not, if this is your first time doing it, you have to install that package first. Do you have, did Elena give you? Okay. Elena, maybe you could show her. So let's load tidyverse into the into here. And I'm going to change this patient data back to a tibble. All right, and now I want to go back up to the previous section, which I skipped, which was lists. And I skipped it because lists are sort of the biggest version of our objects that we have. Vectors are going to be the smallest because that's just one row of data, basically, or one column of data. Tibbles are going to be a data set, okay, like a data frame. It's going to be like a spreadsheet. A list is going to be something that can eclipse all these items. Now, we're not going to create lists. You're not going to create lists, but you're going to get lists back. So when we run models, say we run a linear regression, a logistic regression, a t-test, a correlation, what they are going to give us back is a list. So we're going to have to deal with lists a lot. You're not going to create lists on your own, but you are going to have to deal with them. So that's why it's important for us to talk with them. So lists are more flexible in that, remember when we tried to create a data frame, some of you had the issue where you didn't have enough, say you had 6 IDs and you only had 5 responses, and it gave you an error message. So no, I can't do that. It has to be square. A list, notice it does not have to be square. Name is only has 1 value. Values have 4, and flag only has 1. And you can see how it's almost like there's a separate entity for each element in the list. I want you to copy this, and I want to bring it over to R. I'm going to run this in, and we can see it here. It looks just like it did, on there. So lists can contain a lot of things. So I'm going to create a new list here called big_list. I'm going to set this equal to a list, open close parentheses, and I'm going to put in here patient data. And then I'm going to put in here my list. So this is going to be a list which contains an entire data set and this previous list that I created. Run this in. Let's run it. And then we have here right here. And I could give these things some names. Patient data equals patient data. Old list equals my list. Jazz it up a little bit. Okay, so just to show you that lists can contain a lot of stuff. Okay, so a lot of times you'll get something back that it just looks like this. It may be equal to X, it may be equal to your results, but there's going to be a ton of stuff in it. It can have a whole data set in there. It can have plots in there. You know, it can have a lot of things that are embedded into this one object. And so a lot of times we'll look at these things and we'll explore them and we'll say, okay, what is actually in that object? So lists, it's not something we create. Tables are something we're going to create, something we're going to use. We're going to get downloaded data, we'll turn it into a table. Lists are something we're going to get back. So the results of our model are going to be a list very frequently. Okay. Okay, so this next section, we're going to talk about indexing. So when I say indexing, I mean extracting a particular element or elements from a list, from a table, from a vector, whatever it is. How do we get particular elements out of it? How do we look at particular elements? First, we start off with vectors. Vectors are the most simple objects that we have. So you can see here that we have a vector x equal to 10, 20, 30, 40, 50. If I use x bracket, close brackets, 1, then it is going to give me the first element. If I did x parentheses 1, it would give me an error. If I did x curly 1, it would give me an error. It has to be those closed brackets. If I do x3, it's going to give me the third element of x. If I do x c of 1 comma 3, it's going to give me the first and third elements. If I do x2 colon 4, which remember is 2, 3, 4, it's going to give me elements 2 through 4. If I do x minus 1, it's going to give me everything except for the first element. So we can do it that way as well. All right. So here is where logical vectors come into play. So let's say I'm going to copy this x over into my R. Run it in there. So here I'm going to say, all right, I want to look at x, but I only want to look at values of x that are greater than 25. And then that gives me elements 3, 4, and 5, 30, 40, and 50, because those are all greater than 25. And it gives me that because this x greater than 25 is a logical vector. So when I do x greater than 25, it gives me false, false, true, true, true. So that creates a logical vector, 2 falses, 3 trues, because the first 2 elements are less than 25 and the last 3 elements are greater than 25. So this is where logical vectors come into play when we want to subset our data to only look at particular elements of it. And we could do that just the same way here, giving it an explicit logical index. Okay, let's skip those last two. So data frames, which we created before. How do we index data frames? How do we look at particular parts? We have our patient data that we created before. And you can see we're going to use the closed brackets here. But when we're talking about data frames, we have rows and then we have columns, which we're going to have a comma between. Rows are always first, columns are always second. If we leave one dimension blank, that means all. So if I do patient data comma one, or excuse me, one comma, that is going to give me row one, all columns. Okay, and then we can see it shows us the first row of patient data. If I did patient data comma two, that says second row, excuse me, second column, all rows. Then it gives me back all rows of that second element. If I say patient data 1, 2, that's going to give me first row, second column, which here is equal to A. And that's how you refer to particular elements in your data set. Here we have rows 1 through 3, and then columns 1 and 3, so on and so forth. Another thing we can do, there's two ways we can refer to a particular column or variable. There's actually three ways. So if we wanted to look at the response, we can do patient data bracket comma quote response end quote, and that will give us the response. Go back up to my patient data here. So this is one way we can look at our response values. We could also, this is how we did things yesterday. We can do patient data $ response. Boom, gives me the same thing. Notice it gives it in a little different format. And lastly, we could do patient data bracket comma 3, because it's the third column. That will also give us the same thing. So three different ways to refer to a particular variable, either through the bracket, comma, giving the variable name, the $, or the column number. Most of the time, out of these three, I by far use the $, the most. But there are always a lot of different ways to do the same thing in R. You know, everything kind of has 5 different ways. I try not to show you all 5 of them, but sometimes I think it's important to look at some. All right, let's say we wanted to look at our patient data, but we only wanted to look at those that have a treatment equal to A. So here I'm giving it a logical vector. I'm saying patient data $ treatment. Notice there are 2 equal signs. That is how you create a logical vector, is telling you it's equal to A or not equal to A. You have to use 2 equal signs. You don't use 1. If you use 1, it's going to give you an error message back. But here I'm creating a logical vector saying, all right, let me look at all the rows where the treatment is equal to A, and that gives us rows 1, 3, and 5. Those are the 3 that have have treatment equal to A. If we just looked at this particular part right here, this treatment, patient $ treatment equals A, it should give us a true, false, true, false, true, and we can see that's what it gives us. Again, if I said only 1 equals, then I've messed up my data, I've messed up my data set, because now I've stored all elements of treatment equal to A. So I've changed my data set. Now look, everyone has treatment equal to A, which is not what I wanted. I just wanted to tell me those patients that have a treatment equal to A, which patients have it. Any questions on that? All right, so I'm going to give you 2 minutes here. Use your patient data, and I want you to only print out those rows that have a response greater than 10. So same thing we did previously, but here instead of only looking at patients with treatment A, I want you to get out patients that have a response that is greater than 10 and get it to print out. So give that a shot. I'll give you about a minute and then we'll come back there. Yeah, so you opened up the go to this untitled um, so this is something we talked about. I'm gonna close these two down. These are more complicated than so let's go back to the minus. Copy that. Let's do that. And then when you go up to say line 2, if you cursor there, and you hit command enter, if you have a jump, then it's going to shoot everything down to the console here, which will make the data is actually yellow. And then do the same thing here, command enter. Oops. But there you go, your data. Okay. So, that work okay? So, okay, if you don't have it, that's fine. This is just a little check. We will do this together. So, what I want to do is I only want to look at patients that have a response greater than 10. So let's look at the patient data again. Oh, we have it right here. So our patient data has 3 columns to it. The third column is equal to the response. I only want to get rows where the response is greater than 10. So I want rows 1, 3, and 5. That's what I want to end up getting. So what I do is I look at patient data similar to what we did there. $ response greater than 10, and then a comma. And that's going to tell it, so this part right here, this is going to be a logical vector that's going to be true, false, true, false, true. So that's going to tell me, that's going to tell R, I want rows 1, 3, and 5, and that's what it's going to print out on the console when I hit Control N like that. Now it happens that all the people with treatment A end up having the higher responses here. Yeah. Similar. Any questions about that? Great, great. Okay, now the next one, try to do, well, we'll do this one together. Let's do that. So putting this all together, oh, no, we have a couple of things. Okay, the dollar sign operator. We've used this a lot. We used this a lot yesterday. The dollar sign, we've been using it today already. It's a way to get at particular elements of your data frame. So if we want to look at the response, the treatment, if we want to do the mean of the response, boom. We did a lot of this yesterday. And as we saw yesterday, a really nice thing about our studio is that when I type in patient data dollar sign, it has this auto fill where it tells me all the different variables that I could be looking at. When using regular R, they don't have that. So this is one of the nice things about R Studio. One of the nice features of R Studio is that autofill. The autofill can sometimes drive you crazy, but most of the time it's a nice thing. We can use this dollar sign on lists as well. So this list that we created earlier, if I wanted to look at one element of it, again, my list, dollar sign, and it's going to get all the different things that we have in there for the list. So it's another way we can get it. And let's say I wanted to look at the second element of values. I can stack this where I look at, all right, let's look at my list, dollar sign values. So this is going to give us all the values. And let's say I wanted to look at the second element of that. I would just do close bracket 2, and boom, that gives me the second element of values. So lists are things that we are going to look at a lot. I'm going to skip over this double brackets section because I don't think it is crucial for us. Okay, let's put this all together. So here we are looking at patients with treatment A and a response above 12. So we're putting two logical arguments together. So this one is going to give us true, false, true, false, true. Patient data response greater than 12. That is going to be true, false, false. And when we have an and in the middle, that's going to tell R that this is only equal to true if they are both equal to true. So this is only going to give us rows 1 and 3. It's not going to give us row 5 because even though treatment was equal to A, the response was not greater than 12. So that gave us a true and a false. When we did and, that ends up being false. Another way we could do something like this, so I encourage you to just run that on your own. I'm going to paste it again here. So another thing I could do, let's look at patients that have treatment B and the response is greater than 12. Now, that's actually going to be nobody because both of the patients that have treatment B have responses less than 12. So let's see what happens when I do that one. What does it give me back? It says Tibble 0 by 3. So that tells us there were 0 patients that had those qualifications. Let's do another one. I could say there is also another symbol, the OR symbol, which is the up and down, just this up and down arrow. So here I said patients have treatment B or their response is greater than 12. So that gives me anybody that is either treatment B or their response is greater than 12, which is all subjects except for subject 5, because he's treatment A and his response is less than 12. So we have ands, we have ors, and we'll use these when we're subsetting data. Sometimes we want everybody to have all the characteristics. Sometimes we want to have people that have any of the characteristics. So that's, sometimes we'll use or and sometimes we'll use and. Any questions about that?
I was wondering, is there like an option to do like not as well, like where it's like everyone who's treatment B, but not over like 10 or 9?
So we could use, for that, we could use less than,
Okay.
right? But that's a very good question. There is a not, right? Let's take away the patient response. Let's say I wanted people that did not have treatment A. What we are going to use is an exclamation point and an equal sign. And that's going to give us only people with treatment B. So exclamation point equal sign means not equal to. Very good question. Any other questions? Okay. Then just a little quick reference guide in terms of this section, indexing variables and all that. All right, so now we are gonna start looking at a data set. We're gonna look at a data set that has a lot of different types of variables to it. So what I want you to do first is I want you to install this NYC Flights 13 data set. Guys, remember how to install, what the command is? Install.packages, and you have to have quotes around NYC Flights 13. So install.packages, quotes NYC Flights 13. And that is going to install that package onto your computer. Should already be in this one. And then once it's installed, you'll do library, NYC Flights 13. Again, it's going to give us a warning message, but this should not cause us any issues here. Good. And after that, in your R, I just want you to type NYC sorry, flights. And then with that. So this data set, this flights data set, is something we're going to play around with a little bit. It's a useful data set to subset. We can create new variables from it. It has different variable types. Just a fun one to that we can play around with. Is this a big data set or a small data set? Yeah, how many rows do you see there?
10.
Yeah, lots. There's over 330,000 rows in this data set. It has it has one record for every single flight that went. Let's look at the description of the data set. We haven't used this yet. So to get some information about this data set, what I'm going to do is I want to access the help files for this particular flights data set. And to do that, I'm going to do question mark flights. And then I'm going to hit enter. And when I do that, you see that this bottom right thing, it switched to the health files. And then we have some information about this particular data set. So you can use this question mark whenever you're dealing with a function. If you don't know something about that function, do question mark that function, and it'll give you this nice health file for that data set. So it's on-time data for all flights that departed New York City. So that's either JFK, LaGuardia, or Newark Airport in 2013. And there's a lot of flights that departed any one of these three airports in 2013. So one thing, the fact that this is a Tibble was nice because it only showed us the first 10 rows. It didn't show us the first 1,000 rows. So it didn't just blow up our console here. And when that happens, you have to scroll up a ton to see whatever you did. Also, it only shows us the first 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. It only goes over as far as the screen will go. If we scroll down a little bit, it gives us some information about the other variables. It says there's 10 more variables. Carrier, that's one we're going to use. What was the flight? Was it operated by? Flight, tail number, origin, destination, airtime, distance, so on and so forth. And it tells us what type of variables that we have here. So we have year, which is an integer. Okay, that just means it doesn't have any decimals to it. Month is also an integer. Day, departure time, these are all integers because none of them have any decimals to them. Departure delay, this one says double. That just means it's a number and it can have some decimal points to it. Okay. And we have some other integers and some other numbers. The carrier is a character variable. We'll see that one. We'll use that one in a little bit. And some of the others, the tail number is actually a character variable because that has some alphanumeric characters. Destination is a character. This DTTM, that's another variable type. It's a time variable type that we won't deal with. It's one that you can see. There's actually a lot of different types of variables. The main types of variables that we will use are integer double. That's basically the same thing. Just one has decimals, one doesn't. Just numbers. Characters, logical. We've already used some of those. And then factors. Okay, factors is something we will use very frequently. And factor is something that is usually if you have a variable. Let's say you have like hair color in your data set. And you want to make it into, you want to actually tell R, okay, there's some groups here. Usually we'll turn it into a factor. So factors are usually come from characters. So let's do kind of go together. Then we also have the date time. Won't use as much, but there's some things that comes up. So for the numeric variables, these are ones that we can do mean, standard deviation, range, min, max, anything like that. Now notice here, we have to put NARM equals true. What does that tell R when we do that? When we put the NA.RM equals true? Remember what that tells R to do?
Just skip over any variables that we don't have.
Right, because there's going to be some missing variables here. And so we have to put that in there. So it's saying all variables that don't have a missing value, the mean departure delay is about 12.5 minutes. The standard deviation of that is 40. The range of airtime, so this is a different variable, airtime is 20 minutes to 695 minutes. So a 20-minute flight to a 11.5 hour flight. Big difference there. Character variables. Okay, so as I said, the carrier is a character variable. Okay, so it comes into it with quotes to it. What do I use? How do we summarize character variables? These two are the most common that I will use. First one is unique. That's going to tell me all the unique values of the character variable. So we have UA, you know what that stands for? United Airlines, American Airlines, US Airlines. I don't know what the rest of these are, but
I
there's a
think
bunch
Geo
of
is Delta.
Delta, okay. And this is 2003, so it's like JetBlue. No, I don't see that. Yeah. Florida Airlines, Alaska Airlines, I bet. Hawaiian Airlines. Anyway, so we have all the unique values of the of this character variable, and the next one I use most commonly is table. Okay, table of the character variables tells you how many times each one is in the data set. So let's see which one has the most here. B6, whatever that is, has 54,000. United Airlines has 58,000. I think that's probably the most. US Airlines has 20,000. B6. You have any idea what that is? No? Okay. Anyway, so those are two nice functions to use on character variables. Okay, what are the new unique values? How much does each one? How many times does each one? A lot of times we will want to change how the character variables look. Okay, and that could be we want to change the values of them. Maybe the way the character variables come in are kind of messy. This happens in some of the data I use. One thing that's really hard are country names. Okay, because there are a lot of different ways to do country names in terms of like capitalizations. So sometimes I'll have a data set where some country names are all caps, then you see the same country name. We use the first letter as caps, and then they'll be all lowercase, and then sometimes they're all lowercase. And then there's some countries that have accents on them. Cote d'Ivoire. Okay, sometimes it has an accent, sometimes the data set doesn't have an accent. So you need to change your data so that it's more uniform. So these functions here are ways that we can change it. These are all from the string R package. All the functions start with str. They're pretty simple. So we have a character vector here, X, control group, treatment group A, treatment group B. If we want to change them to all lowercase, boom, we can do that. The nice thing to do if we want to change it to all uppercase, boom, we can do that. If we want the length of each one of these character variables, that is how many characters is each one taking, we can look at the length. Here we can detect certain text in a character variable. So here we're saying, I want you to find all the values of X that contain the word control. I could also do this with group. They all have group though. But I say, hey, find me all the ones that contain the word control, and I get true, false, false, because the first one is the only one that has control in it. So that's really useful when you want to find a particular character variable and you want to subset your data to a particular character variable. This function right here. So I can say, all right, give me all those that have some character combination here, all those that have control. The next one is also one that is really useful. You can replace particular parts of your character variable. So let's say you don't like group, you want arm. Similar words that we have when we have a study, sometimes we call them treatment arms, sometimes we call them treatment groups. So let's change group to arm, boom, we've changed it. Okay, so now we create a new vector that has those ones there. Here's a situation where we are going to use this detect variable. So I'm saying, all right, I want you to detect all carriers that that start with a U. And how we do that is quote caret U. So that's only going to find those that start with U. There's different code we can use to find only those that end with U. There's a lot of different parts to this. Again, we're not about memorization, just about learning, hey, what can I do here? This finds us, this will give us a bunch of trues and false. Now I'm putting a table around it, and we're saying, okay, we find there's 79,201 trues. The rest of them are falses. So the ones that start with U, we can go back up to the table here, are United Airlines and US Airlines. So we get the sum of those two, and it ends up being the same thing that we get down here. About 79,000 flights were either United Airlines or US Airlines. So these are some of the ways that we can manipulate character variables and some of the things that we can do with character variables. Okay, with the string R package. Okay. Sorry, just. Okay. Logical variables. Again, these are trues and falses. That we've used these before. You can do a table of logical variables. You can do a sum. You can do a mean. So how does a sum and a mean work for a logical variable? Well, what R will do, it will count trues as ones and falses as zero. So when he asks for a sum, that's going to give you how many trues there are. When he asks for a mean, that's going to give you what proportion of the responses are true. So this says 40% of all flights had an arrival delay of greater than zero. So they had some delay to them. 40% of all flights. In total, it's 113,000. So about half of them. So some of the things we can do with logical variables, more limited. Table, sum, mean, that's kind of the main summaries that we would want to get from a logical variable. Factors. Factors are going to be very important when we do modeling. Okay, they're very important when we do modeling. Anyone here heard of dummy coding a variable? Okay, so what dummy coding is, so let's say that in our data set, let's say we have a race variable and that we have 4 different race categories. And let's say we want to put that variable in our model and we want to see what the impact of race is. We can't put that variable in as a 1, 2, 3, 4 because the numbers don't mean anything, right? I mean, these are different categories. So what we do is instead of putting 1, 2, 3, 4 in, we take those 4 categories and we split them up into 3 different variables. One variable is going to be our reference group. First variable is going to say, okay, are you category 1 or are you category 2? Second variable is going to say, are you category 1 or category 3? Third variable is going to say category 1 or category 4. So we split them into one reference group and then 3 different non-reference groups. Factor is going to do this for us. Whenever we have a variable like race, like hair color, something where the order doesn't matter at all. Education is another one. There is kind of an ordering to education, but not really. So whenever we want to put something like that into our analysis, factors are what we are going to want to use. So these are usually character variables. So this section right here is showing us how we are going to create a factor variable. So we're going to start with this vector where, let's say this is some categorical predictor. I don't know how bad somebody's rash is, something like that. We have mild, severe, moderate, mild, severe. So that's the data that we have. there's 3 levels of this, mild, moderate, severe. And when we put factor around this, we've told R, okay, this is a factor. So if this goes in any type of modeling, we're going to use that dummy coding idea to represent it. So when you look at a factor, notice it looks a little different than normal. It shows us the data, but then it also shows us the levels to it below. We can use the level command to see. It's like give us the levels. Again, we can use table around it. Again, so when this is important, this is when you are doing modeling. Because a lot of times, for example, in the data set we're going to use this afternoon, there's variables in that data set, it's a Framingham Hart data set, where the way the data come in for a variable like this, for like education or like race, it will come in as a numeric variable saying 1, 2, 3, 4, or 1, 2, 3, 4, 5. And we got to tell R, hey, that's not a numeric variable. It's really like, this is a factor, these are categories. You have to treat that variable differently than you treat age or weight. That's when we bring the factor component into it. It's vital when you're running a model. It's one of the most common options, one of the most common mistakes is not transforming a variable to a factor when you should, okay? Because the R is not going to tell you made a mistake. Let's say you have race in there, race came in as 1, 2, 3, 4, and you just put it in. R is going to treat it as 1, 2, 3, 4. It's going to treat 2 as bigger than 1. It's going to treat 3 as bigger than 2. You don't tell it, it's not going to know. So very common mistake in modeling. So these are going to be very, very important when we start our modeling. But we're going to start this right away in the PM section. We're going to create some factor variables, some factors. So the flight's $origin. Let's take a look at that one. Let's look at unique flight's $origin. So like this is referring. Oh, sorry. Yeah. So just this one. Yeah, just origin. So flight's $origin. There we can see that there's 3 different Newark, LaGuardia, or JFK. I do a table. Tells me how many came from each. Actually, most of them came from Newark. And here I'm going to create a factor from this. Notice I don't have to use the levels argument. If you don't, R will figure that out by itself. Now, if I just look at this flights variable, flights $origin, using FTC for factor. If I look at the first 5 elements of it, boom, it gives me now we can see that it's a factor. And for most of the stuff, everything between character variables and factor variables is going to work the same. It's just when we start modeling that they're not going to be treated the same. The reference level is something that's important to set. This gives you some code for how to set that. We can collapse levels here. So let's get this. Let's all go back and get this severity variable. Let's put it on our script here. Mild, severe, moderate, mild, severe. So we can recode this. And now I'm changing the data. So I'm saying instead of using mild, moderate, severe, let's use grade 1, grade 2, and grade 3. We've recoded this, and now we've changed the levels of that. We can collapse levels. So let's say we wanted to combine let's say we wanted to combine the levels moderate and severe, which we commonly do, we can use this FCT collapse. And when we do that now, okay, now we just have high and low. There's a lot of different ways we can change these factor variables through these FTC functions, FTC recode, FTC collapse. So these will be things that we are definitely going to want to use when we start modeling. Awesome. Let's take a quick 15-minute break. Try to get back here at 11:20, and we'll start off with the second portion of this morning part. We'll get into some of the Dippler stuff. All right. I'll see you back here at 11:20. Again. Good. Great. So the things we've gone through so far. We've talked about filtering data, we've talked about selecting particular rows, and we've done this in what's called the base R system. Now we're going to switch to doing things with in the DPLYR, Dippler it's commonly called. These are very useful ways for managing, manipulating data, subsetting data, getting summaries of data, all that kind of stuff. And it has some nice things to it. To do this, again, make sure you have the tidyverse package loaded. Dippler is one of the packages that gets loaded when you have tidyverse, and we're going to use the flights package again. So the way Dippler works is it uses something called a piping command, which I think of piping as you're taking data and you're sort of slipping it to the next row. And it creates something where when you want to do something very complicated, the piping allows you to split it into a number of simple steps to do it. So let's go to R here. I'm going to create a new R script here. Okay, so a new file. And there was some questions about when do we have things in the R script? When do we have things in the console? The scripts, remember, these are just notebooks. It's just like a notebook where you're jotting things down. So I'm going to put anything in the scripts that I might want to use again, that I may want to change, something like that. Okay, I'm going to use the scripts over here. I'm going to write flights over here. Okay, and then I want you on your computer to hit Control-Shift-M or Command-Shift-M if you have a Mac. And when you do that, when you hit Control-Shift-M or Command-Shift-M, it may look like this, like I have it right here. Does anyone have it so it doesn't look like this? Look like this for everybody? Percent greater than percent. Okay, so the other way it may look is like it does in the notes with this bar greater than. Those are exactly the same thing. Okay, the bar greater than is a newer version of the percent greater than percent. And what that means is then. Okay, it means then. So how we would use this, there's a number of functions here that we'll talk about. Filter, mutate, summarize. So others that we'll get into, but these are some of the main ones. Now, how are we going to use these? So, for example, we may say flights, and then I have the whatever we have, then filter, and inside the filter function, I'm going to put some logical argument there. So filter such that the carrier is United Airlines, UA, filter such that the departure delay is greater than 20, filter such that the departure delay is less than 0, whatever we have. So that's gonna subset my data, so I only have certain rows of the data set. Then, once I filter it, I'm gonna send it over to mutate. Mutate is where we're gonna create new variables. Okay, so we may wanna change the, make a variable into a factor. There's some other things that we can do. So this will, mutate will create new columns. And lastly, summarize, this is where we can get the average value of the delay, or how many delays were greater, what percentage of flights were delayed by over an hour, or something like that. Okay, so Dippler, we do things line by line. It creates cleaner code, and it's more obvious what's happening. So, for example, let's say we only wanted to look at flights that had an arrival delay greater than 120 minutes. So they were delayed by more than 2 hours. So flights, I hit that Shift Control N, then I'm going to do filter. And here, I don't have to use the $sign. That's the nice thing about this. I only have to tell it what column I'm talking about. I don't have to do flights $sign arrival delay, because it already knows the data set. That's the benefit of the piping, is that you don't have to use $sign. It knows what the variables are. So instead of doing flights $sign arrival delay, I'm just going to use arrival delay, and notice it fills this in for me, greater than 120. So that's going to create a data set over 10,000 rows. These are all the flights that were had an arrival delay of greater than 2 hours. And similarly, we could look at all those that have an arrival delay greater than 3 hours. You can see there's 3,800 those, all those that are greater than 4 hours, so on and so forth. So this is how we can subset our data using this filter. And again, recommend you try this out on your own. Filter for some different arrival delays. We should notice you can do departure delays also. Departure delay of over 6 hours. The filter is one we'll use a lot. Now here we're gonna in this next filtering command, we're only gonna look at those flights that are departing in January, and only those that are on United Airlines or American Airlines. Okay, so let's write this ourselves. Flights, filter month is going to be equal to 1, and carrier. And this is a neat one to use, percent in percent C of UA. United Airlines, what was that one? American Airlines. Okay, there's a lot going on this command. Control Enter. This will put it over to the console. And we can see that everything is in month 1. If we looked at it further, we would see the carriers are all United or American Airlines. Okay, so I say, all right, flights, then, and I have my filtering command. I have an ampersand in the middle, so that means and. So it has to be month one, and the second part has to be true. Now, what does this percent in percent do? So that's just a way of saying the carrier is UA or the carrier is AA. So this percent in percent, just saying if it's anywhere in that vector that we have on the right, it'll be equal to true. So this is going to be equal to true when it's equal to either of these. Another thing that's a little different about this is the fact that we use multiple lines. Okay, so earlier we were writing everything on one line. Now we're using multiple lines to do this. When you write your code in multiple lines, it's just easier to read when you come back to it. It's not this one huge long string. It's something that you can look back and it creates a little bit cleaner code than what we had previously. And it gives us our response. So we really start having a very powerful way of subsetting the data. So I'm going to do one more of these here. So I'm going to do flights. Filter. And let's say we wanted any month, but we wanted the carrier to be either United, American, or Delta. Let's say I wanted to look at those three carriers. How would I change? What would I put in this filter versus what we had last time? So we're not going to have the month one part on there. We're just going to have the carrier part. And what we want to do is we want to add one more airline to this filtering, not just United and American. We want to add Delta. Being muted. We don't. It's actually more simple than that. More simple than that.
You just break Canada and just add Delta into the.
Yeah, exactly. So we're going to use the same command that we had before. Carrier percent in percent. Now we're going to have UA like we did before. We're going to have AA, and then we're going to have Delta. So, and whatever I can see, that's gonna give us our data set that we want. So when we do this, it prints the new data set on the console, but we can't really look at everything, right? We only see the first 10 rows. We can't look at all the columns. Let's say you want to look at the whole data set. You want to peruse, you want to scroll around. How we are going to do that is we're going to add a command called view. Again, I'm going to use this piping command like this. And now I'm going to do view, which view has a capital V, capital V-I-E-W. And so same command as I had before. I have the percent that I'm adding, and then this view. And when I hit run or control enter, this new data set is going to pop up right here. And now I can peruse the whole data set. I all the rows are here. It's not just gonna show us the first 10 rows. We can look at all about 140,000 rows to this. And we can see that the carriers, they're all UA, AA, or DL. And we can see all the data to it. So whenever you want to look at your data more like a spreadsheet, you use the view command. And we can use that with the piping and say, all right, here's our data set. Then I want to filter it. Then I want to view it. Okay, so it kind of has that logic to it. I'm just going to X this out. And you can do that anytime you want. And the view has some nice features that we'll get to later on. Pretty good. Any questions?
My particular command, like the piping command, isn't working. It's getting an error message.
Okay, what's the error message say?
It says a find function.
Yeah, I had the same one. I switched to the bar and the.
So, oh, really? Interesting. So you have the tidyverse loaded. Yeah. Okay. Very interesting issue here. So what happened was I think in some of the newer versions of tidyverse, they don't recognize this percent greater than percent anymore. You have to use the bar greater than. Okay. Now, how you can do that? You can write it every time, bar greater than every time, okay, without the shortcut key, or you can go up to tools, go down to, let's go to modify keyboard shortcuts. Okay, click that. I'm doing this on the fly here, so let's hope this works. So on the filter, I'm going to hit Control Enter. Okay, so what I'm going to do, should not be trying to do this on the fly. So what we can do, I'll work on this during lunch, but we can change the keyboard shortcuts. So Command Shift M does your appropriate bar greater than instead of the percent greater than percent. That would be the change that you would make. So for now, just if you're getting an error, type in this command manually. And this command here, this works on, so on the older versions, I think you can use, yeah, so on mine you can use both, but I think on the newer versions, they made it so it will only work with the newer command. Yeah. Thank you for asking that, because I'm sure that's happening. And the thing is, the way these packages work are different on different computers a lot of time. And I don't always know how, one computer or another computer is going to act with some of these. So if you have an issue like that, please let me know right away, because that means somebody else is also. Okay. So here are some of those logical arguments we can use. Percent equals, we can do equals, not equal to, is dot NA. That's one we can use. Here, this is let's skip it. All right. So one of the next things we can do, select and rename. Select, this is what we will use when we only want to look at particular columns. So, hey, we don't want to look at this whole flights data set. We just want to look at year, month, day, carrier, departure delay, arrival delay, say. So we can use select. That's only going to give us a subset of the columns. We use filter to only get a subset of the rows. We use select to only get a subset of the columns. So here we explicitly write out all the rows that we want. Here we say, I want all the rows from year to departure time. It gives us all those. And then rename very simply. This is just renaming variables. Okay, just changing the variable names. So the variable name, the old name was tailnum. Now I'm changing it to tail underscore number so that it's a little more clear. And then I'm using select to say, just show me tail number and carrier. Give me those two variables. So we have select, we have rename, we have filter, we have.
I figured out how to change the type. If you want to do that.
Sure. How do we do it?
You go to tools, global options,
Oh,
and
that's
then
right.
code,
Code.
and then there's a checkbox for use native pipe operator.
Okay, use native pipe operator. Okay, then I hit apply. Okay, and now let's try it out. All right, then we have it. Good job. So again, tools, global options, code, and then use native pipe operator. This one. Have that box checked, and then we'll all have the same pipe operator. Did that help? Nice. Good job. Thank you, Elena. Okay, so filter is a big one. Filter is one we're going to use a lot. Select is a nice one because a lot of times we have a huge data set. We don't want to look at all the variables. Okay, so we can trim the number of variables that we can rename. Of course, we want to rename variables every time. Here, this is a sort of a fancy way of selecting variables. So let's say we wanted to select all variables where the variable name has time in it anywhere. We can say select all those that contain time. So all those variables that have time anywhere in the name. Okay, so it has time in the beginning and the end, anywhere, and it gives us those variables. Okay, the next biggest one is mutate. Okay, filter and mutate honestly are the biggest two. So mutate is what we're going to do when we want to create a new variable. All right, we want to create a new variable, and here we're going to create 3 new variables. The first one is going to be the departure delay minus the arrival delay. So what's the idea here? Well, if the departure delay is 20 minutes and the arrival delay is 0 minutes, that means they gained 20 minutes in the air, right? They left a little bit late, but they still got there on time. So the gain there would be equal to 20. If the departure delay was equal to 0 and the arrival delay was equal to 20 minutes, that means they lost time in the air. They left on time, they should have got there on time, they got there 20 minutes late. The gain would be equal to negative. So this is another variable that we can create. The speed in miles per hour. We look at the distance, we divide by air time, multiply by 60. That gives us the speed of the average speed of the aircraft. Late. This is going to be a logical variable. It's going to be equal to true if the arrival delay was late. If the arrival delay was greater than 0, it's going to be equal to false otherwise. And then we can see this. Then we're going to just select, we're just going to look at carrier, we're going to look at gain, speed, and late. And these are the variables that we have. Okay, so we have the carrier, United Airlines, this one, 9 minutes, so it lost 9 minutes in the air. So for example, it left on time, it got there 9 minutes late. Average speed was 370 miles per hour. Was it late? Yes, it was late. You can have some different ones here. There, B6, JetBlue, really flying there with 517 miles per hour, and actually gained 17 minutes, 17 minutes in the air. So it was probably going so fast because it was trying it went fast and then it ended up gaining some time. Okay, so mutate is definitely one that we are going to use a lot. This is also where we can create factors. Okay, so we can create factors in our mutate. So we have the regular month variable, which is character. Now we're going to create a factor version where I say the levels are going to be 1 through 12, because the month is a numeric variable. The labels means this month.abb, which is equal to Jan, Feb, Mar, so on and so forth. And then we can see what results. This count variable is similar to table. It gives us how many flights by month there were. And now we can see this month factor gives us back Jan, Feb, Mar, April instead of 1 through 12. The mutate is one we are definitely going to use lots. So when you use mutate, something that I use commonly is if else or case when. So if else is one way to take a variable like airtime and switch it into here 2 different categories. So what I'm saying here, I'm going to create a new variable called long flights. If the airtime is greater than 300 minutes, so it's greater than 5 hours, it's going to be equal to short. If that's not true, it's going to be equal to long. If that's not true, it's going to be equal to short. So this is going to give us one of those 2 values. So this is a way you can tell R, hey, if it's this, set it equal to that. If it's this, set it equal to that. You can go in between the 2. And then you can see the resulting variable, this long and short. Case when is more complicated than if else, but it follows the same it follows the same idea. So now I'm going to create a delayed category. So if else is good for 2 levels. Case when is what you use when you have more than 2 levels. So if the departure delay was less than 0, it's going to be equal to on time or early. Then if it's not, we go to the next line. If the departure delay was less than 30 minutes, minor delay. If not, so if we have false, we're going to go to the 3rd one, which is moderate delay. And then the last one we're going to say is everything else. That's going to be equal to major delay. So then we can see this variable that we created. We have a categorical variable now, major delay, minor delay, moderate delay, and then finally on time. So case when is a little more complicated, but it's very useful when you're creating a variable that has a whole bunch of different categories to it. And lastly, 2 more we're going to do. This one, very simple, arrange. Just going to sort our data according to whatever we want to sort it. Okay? So what we're going to do here is we're going to sort the data by departure delay. This descending means sort it so that the biggest values are on top. If we don't have that, it's going to have it so that the smallest values are on top. And we can see the most delayed flight was from Hawaiian Airlines, from JFK to Honolulu, which was delayed by 1,300 minutes, which is almost a day. It's a long time. And we see some of the others here. So this is a way that we can get certain values put right to the top using a range. So a range sorting, very simple. Here's one where we're gonna mutate, we're gonna create a new variable count, and then we're gonna arrange it. We'll go over this. We'll go over this in a second. The last one, group by and summaries. So this is when we're actually summarizing data. Okay, so we're actually wanting to look at averages, we're wanting to look at percentages, something like that. What group by does is group by lets us look at summaries by a particular character variable or a factor. So here we're going to look at the average arrival delay. We're going to look at the number of flights. We're going to do it by carrier. So what R is going to give back to us, it's for each carrier, it's going to give us the average arrival delay, and it's going to give us how many flights carrier had. And now I'm going to arrange it in terms of this average delay. So the carriers that are on top, those are the carriers that had the largest delays. The carriers on the bottom are the ones that had the smallest delays. So the largest delays, a bunch of airlines I don't know. JetBlue is B6. Alaska, Hawaiian Airlines, American Airlines, those are the ones that have the smallest delays. Delta's right up there as well. That Alaska Airlines actually has a negative delay, meaning it's usually early. Hawaiian Airlines actually has a negative delay, meaning it's early as well. Any idea why those flights would do better than some of the other ones? What's that? Less that is true. So they do have not quite as a smaller number of flights. That may have something to do with it. I was thinking the distance.
Oh, yeah.
So I think when you're doing a lot of short flights, it's easy to get a lot of delays. And when you're doing like a few long flights, usually you can make up the time in the air or something like that. So you're not going to be too bad. There may be some relationship between the distance of the flight and the delay that's making those look better than maybe they are. So we will do this a lot. Okay, this is something we're going to do a lot in the PM lab, and you're going to do this a lot in real life because this is something that you'll be interested in. Hey, what's the average systolic blood pressure among all these different groups? You do a group by, and then you do a mean of systolic blood pressure, for example. So that's something that we put together a lot, these group by and summarize together. How the summarize works, so it's kind of like mutate, where we're saying, all right, we're creating a new variable called mean delay, which is equal to the mean of arrival delay, na.rm equals true. This n function, that's going to count how many values there are. So the number of flights for F9, 685. That's what that n function does. And then again, putting on the arrange just arranges these so that we can look at them from max to min, the best things to the worst. This is the same thing. We're grouping it by origin and carrier. So we're looking at the we can take a look at this one. This one's going to be a little bigger. So I can look at it here, but what I can also do is I can add a view after this. So then we can look at the whole, all of these at once. So now for each origin, for each carrier, we have the mean delay, and we have how many flights there were. And again, we could sort this. Descending by mean delay. And view it. So F9 from LaGuardia that had the largest mean delay. Alaska Airlines to Newark that had the shortest mean delay, and so on and so forth. We can see which one had the most flights to if we wanted to. We looked at we sorted this by end. Okay, the most flights was Newark, United Airlines, 46,000 flights. All right, putting it all together, we have a lot of things going on in this code right here. But the nice thing about the piping is it is relatively readable, relatively easy to discern what's happening. Starting with our flights data set, and we're going to filter it. We're only going to look at flights that are greater than 500 miles. Okay, so we're filtering our data set. That's the only row set limit. We're going to create a new variable on time, which is going to be a logical variable that's true if the arrival delay is 0 or less, false otherwise. Then we're going to group by carrier. So the summarized results we're going to get are going to be different for all the carriers that we have. We're going to get the number, how many flights for each carrier. Then we're going to look at the percentage of on time, which is going to be the mean of this on time variable. That's going to be equal to 1, basically, if it's on time is 0 otherwise. So the mean is going to be the proportion of on times, and multiply that by 100 to get only those that, to make it 0 to 100. We're going to take those results, we're going to filter them. We're only going to look at carriers that have at least 1,000 flights. So we're not interested in carriers that have a tiny number of flights. That kind of gets us to a place that we're only talking about bigger carriers. And then we're going to arrange it by the percentage of on time going down. You can see this right here. So the top airline is going to be at the top, the one with the highest percentage of on-time arrivals. So American Airlines, 2/3 of the time, their arrival is on time or faster. Pretty good. Delta also up there, US Airlines, United Airlines. I mean, all these top 5 are pretty close. We're talking 66% to 61%. And then some of the ones at the bottom are not doing as well. I don't know if it's Florida Airlines or what, but they're only on time 38% of the time. They're going to be late more often than they are on time. All right, we're going to skip section 6, take a lunch break, come back in the afternoon. We're going to get to the PM. We're going to jump right into the PM lab. We'll skip section 6 for now. We'll hit that later if we got time. We're going to get back into Quarto. We're going to download some data. We're going to load in some data, and we're going to use some of the stuff that we implemented in here on the Framingham Heart data set, so we can look at some summaries by different groups, start putting this stuff more into action.